Make sure I go live before I start blasting this out. Hey, looks like we're live. Welcome to another. Here we go. Unity 3D GamDev live stream with your.
Good job.
I got it out in one shot. With my name is Charles, and this is Infallible Code, the channel, and we've got Jason Story here, software developer, game developer, and what we're going to do today is we're going to discuss game dev. We're going to discuss, if any questions arise that you have, we can talk about that, programming related, game development related, Unity related. And then in a little bit, we're actually going to open up some code, and the code that we're going to open is from my most recent video, where we did a refactoring of what I would consider to be the beginnings of a monolithic class. So yeah, we're gonna do all that today. Right now, I'm gonna be pushing these out on Twitter and Discord. So give me a second. But Jason, what do you got? You got anything? Got any comments on the video? I put you on
I'll
the
be
spot. I love to
honest.
do that.
No, seriously, I like this isn't set up. He just asked me off the cuff. I honestly think it's one of the better videos, at least one of my favorites,
Well,
simply
thank
because
you.
I think it's one of the more interesting topics.
Mm,
It's one that I think is very hard for people to do. Like it's kind of hard to understand when it's appropriate, and it brought up a lot of interesting points. And I think a lot of people recognize that something feels off when a file gets too big.
mhm.
They don't know how to solve that problem though. So I think it's a very interesting topic, and I think it resonated with quite a lot of people who look at it and go, "Yep, that's my project. I'm used to a giant project."
Yeah, yeah. That's one of those things where that's like I think the first code smell when you notice a class getting too long, but I don't think it has to be the first code smell, you know? And I got a comment about, someone was mentioning that the class that we were refactoring in that video wasn't necessarily a monolith at that time, which you could argue that it was or it wasn't, but it wasn't very long. To be honest, I actually have it
Yeah,
right
I
here.
think I think semantically, I think it's from a terminology perspective.
Hmm.
Maybe monolith is the wrong word.
Hmm.
I would say a god class might have been more accurate because it's less the fact that it was gigantic in size and more
Hmm.
the fact that it had too many collaborators and was doing too many things that wasn't
Right.
its job. It was hard to define. If someone asks you what does this class do and you say it does X and Y and Z, then you're already that's your problem, right? That's your god class. It's doing more things than you can describe with a discrete sentence.
Yeah, that's actually kind of a new term for me, the God class, but I really like it because it's true. Like that's the essence. Monolith, like a class being monolithic, is just one symptom of a bigger problem. And I think really the real problem is when you have a God class that just does way too much.
Yeah.
Funny enough, like when you think about, so you think about a class that's like a monolith, a God class, just has so many things it's controlling, but when you think of like a singleton, typically singletons, funnily enough, are not really god classes. Singletons, I find, typically have one job that is well
Mm.
defined, like an audio system, or like maybe even like a player manager or something like that. It's kind of funny how like you have these different, I guess you call it anti patterns or maybe problems,
Well,
code smells. What do you think?
yeah, no, it does. But then, of course, the problem people start with a singleton that represents a single feature. When they realize they can do that, they end up having a service locator, which starts to become a singleton that houses singletons, and all of a sudden you end up with the same problem, but just sort of nested in another layer of layers.
Yeah, yeah, that's actually where it usually goes. It just gets
Yeah.
layered in complexity. And really, I don't know. I feel like that's the one thing that as a developer, one of your goals, your programmer, one of your goals should be to avoid as much complexity as possible.
Mm. I think
Um,
that'll be a good topic. I think that'll be the theme of this overall video because I find that there's two camps of people when they talk about refactoring. There's people who go, refactoring just means tidying it up a bit, and
mhm,
that's fine.
mhm.
And if you do any more than that, you're adding too much complexity. And then there's people who just go ham and add a load of complexity. And it basically boils down to a misunderstanding of what the point is.
Mhm.
And I think it'll be interesting to see how that evolves as we go through this, is that we start talking about why are you refactoring? What benefit does it give you and when should you do it? And I think there's a lot of misconceptions in and around that topic, right? I think a lot of people think it means either make the code easier to read,
Mhm.
just that, or that it means you're basically trying to make as many small classes as humanly possible. And obviously that's not the right answer either, right? Like there's a neat middle ground you can walk, and it comes down to the fact that there are a million different tools at your disposal, decoupling classes, and if you just use one solution for all of them, you'll end up with just the same problem nested in different ways. Like the singleton, right? A singleton in and of itself can be fine, but a singleton kind of invading your code base is not fine. So it comes down to using the right tool in the right amount at the right problems, you know?
Yeah, yeah. I mean, honestly, that's why a lot of questions that we get in the Discord, by the way, if you're not on our Discord server, check that out. A lot of those questions we have to answer with, well, it just depends, because honestly,
Yeah,
all
very
answers are new.
unsatisfying. I
Yeah.
I always say that. I always say, "I know this is an unsatisfying answer," and I love the phrase, "How long is a piece of string?" Because I just think that really sums up
Mm,
a lot of the programming questions.
yeah.
People ask you, "Hey, how long is this piece of string?" You're like, "What piece of string?" And well, that's just a general, like, that doesn't mean anything. Like, what? So a lot of programming questions boil down to, "How should I do X?" And it's like, "Well, what platform are you on? How big is the project? And, how long is the life cycle of the project? And is it going to extend in certain directions?" And there's no direct answer. There is a series of tools, and you should learn how to use the tools and what they're for. And then when you hit a problem, you'll be better equipped to apply the right ones to the right problems.
Yeah, yeah, and every answer is nuanced, and it's interesting too. You just brought up a very particular point that it took me a while to wrap my mind around because I've always been the kind of developer that I almost want to refactor just to refactor, but when you think about like what is the life cycle of a project, an example of this is I'm working on a very small VR project at work, and I know that this is a one and done thing. It's simply a prototypical type deal where we just want to get some cool looking demo to show off to some people, and that's it. It's never going to go anywhere else. I mean, it's literally been stated that we don't want to take this anywhere else. So why would I go to the trouble of refactoring my code? I'm going to do my best to make it as clean and easy to read as possible the first time I write it. But any hacky things that I do, I'm not going to go to the trouble of trying to over architect it. And it's like now as I'm more experienced, I can look at code that I know is for a project that has a very short life cycle, and I can reasonably say I don't need to touch this anymore. I can let it live as it is, which is not in the best state.
Yeah, because let's be real. Like the reason you refactor is because something is hard to maintain and manage.
Mhm.
That's usually the main point of it. Like you're refactoring it because you're either estimating it's either hard to work with, or you're estimating this is not finished and you want to refactor it so the next pieces plug in easy. So a good example of this, there is a kind of refactoring where you take an old project and you want to refactor it. And the reason you tend to do that is because someone asked you to add new features to an old project and you don't have any idea what the current project is doing. So the refactoring is acting as a form of documentation. As you're going through the code to find out what it's doing, to split it up into workable chunks. So the point of refactoring in that instance is in preparation for adding new features.
Mhm.
The second kind of refactoring is, in my mind at least, is if you're working on a kind of more test-driven approach, it's the red green refactor. It's where you are refactoring a small chunk. So we're not talking about application scale. We're talking about, I've built a little piece of code. I will make it work. I will add some features to it. I will make sure it works, and then I'll refactor it and see, can I make it cleaner than I originally wrote it, but maintain it having the same features that it used to. And they're both technically the same thing, but the point of them is, one is to basically allow you to tidy up something that you purposefully wrote badly, because
Mhm.
the point is that you're doing it in small iterative cycles. And the other one is trying to understand the code base. And realistically, if you do the second one, you don't need to do the first one. And that's sort of the point, right? Like if you can do things in small incremental chunks, you don't need to refactor at a giant scale and have to go through like a 3 month long project of just refactoring an existing project.
Yeah. It's interesting, you brought up the refactoring and test-driven development, and funnily enough, the sometimes with TDD you do write like a poor implementation first. Like if you had a test that expected the result to be 10, you could have a function that literally returns 10. You know, obviously it doesn't make any sense. You wouldn't want to do that, but when you first get the test running, the cycle is what is it? Fail Fail pass refactor, I think is what the
There's red green refactor, and
red
then
green
there.
refactor, yeah. So basically, you get it to fail, you write your test, it fails because there's no code that's implemented. Then you implement it with like the dumbest possible code, meaning like you return a static value. And then the refactors where you go in and you can say, okay, I'm going to take that static value. I know that's not right. I'm going to refactor it into like a parameter on the method or something like that. Or. So yeah, refactoring is even in itself. It's now that I'm thinking about it, it's funny. There's so much to talk about in refactoring and
Yeah.
contextually as well.
Like, and I think as well, like a lot of people, like here's the funny thing in my mind about refactoring. A lot of complaints you hear people say about the idea is that when you refactor a system, you're adding complexity to it. They're
Mm,
going, well, it doesn't need all that complexity. Well, if you take the red green refactor approach from a test driven angle, the refactoring happens behind a boundary you've just drawn.
mm.
So what I mean by that is you build a system which is person like say you've got a class. That doesn't make. I'm trying to find something. I was gonna say a class like a school like classroom, and having a class called classroom is
Oh,
anyway.
no.
Yeah, I immediately starting with complexity here, but anyway.
Educational center facility? No, that's terrible.
Yeah. So say you had a grades right for this classroom, we'll say, and you have a classroom object, and you say get grades. Now the first version of that could just be an internal list, stores them when you return them, and that'll work, right? You just kind of like Charles was saying, you just return physically hard coded answers to those questions. The refactoring could be adding a load of other stuff in there and sort of over time extracting out a collaborator and turning it into a repository and then patching it to a database. But whatever that was at the front is still only seeing get grades. So the point of that boundary line is to say, this is the feature set I would like to exist at this boundary line. So all of that extra complexity you're seeing should only be seen if you're already inside of it, right? That's like for example, your mobile phone through each generation is getting more complicated. All of the extra pieces inside of it are getting smaller and more connected. And the reason why cameras are moved around and why we have notches and stuff now are to allow for more important and interesting changes to parts. But you don't see that because it's
Mm,
all hidden under that layer underneath your phone. Your interface to your phone is still the same thing. It's still a screen with buttons and a camera and that kind of thing. So even though conceptually people are improving and refactoring the code behind your phone, you don't see it. And so I don't really buy that argument that
mm,
it's making your code more complicated. It might make it more complicated for somebody managing the code after you if they don't understand what's going on. But even that, I think, is a spurious argument because the whole point of design patterns and that sort of mental sort of approach to things is there are named solutions to known problems.
mhm,
So it should be less complicated to say this is the repository inside the persistence layer, which may not mean much to some of you, but to me, if someone says that, I get a lot of information out of that sentence. I know what the architecture is. I know what the boundary line is. I have good estimates for how things should look. I could map the idea of what they just told me from 3 words because they're using known terminology for an abstraction layer. I would know a lot less if they said something like, "Here is my stuff getter class, which has a bunch of stuff behind it, and I have to now guess every single step of that direction. What are they using? How are they separating it? What are they getting things? Are they using any kind of mapping objects? I don't know any of this information, but I would if I knew that they were using sort of standard practices and refactoring approaches, right?
yeah, you have a language that, you understand, that you can speak, and it takes away the complexity, even though it is technically more complex. And I was gonna say too that you used the word complicated, and I think that gets misconstrued with complexity.
Mm,
Complicating your code and making it more complex. Just I think most developers kind of use those interchangeably, but complexity doesn't necessarily. Because look, if you think of the word complicated, it has this negative connotation. You think of, well, it's complicated. That means it's harder to follow. It's harder to work with and maintain. But complexity, although it does add more, I guess, more to your code, more to consider, more to have to think about. It also, at the same times, if you're using design patterns or if you're leveraging a shared language, complexity, a lot of the times you don't even have to think about the complexity. All you have to do is know it's there, but you don't actually have to dive into the details in your mind. And that's where
mm,
complication comes in. So this class that we're going to look at, in and of itself, is very complicated. When we refactor it, it's going to become more complex architecturally, but it's going to be less complicated because if you're not concerned about input, you don't even need to think about input. You know it's there because it's been architected in a complex way where we're going to have an input handling class. But as long as you don't care about input handling, you don't even have to think about it. And I think that's where complexity actually makes this code less complicated in the long run.
I think that's also a very good point. Is that at the end of the day, so what I was talking about was the contract you have with the outgoing code. So you have button pressed or mouse clicked function. And that seems very straightforward. And you could write the 2 or 3 lines of code inside of there, or you could have it provided by something or handled elsewhere by a
Mhm.
handler. And while that may add extra layers, and let's be real, like you cannot refactor your code into bite-sized chunks and not have more classes. That's
Mm,
just a fact of how like that's just how it works. But you can avoid class explosion
mm,
by managing when you do it and why you do it.
mm,
So it will get more difficult to work with if you are new to a system. That is undeniably true. It is easier to open a file with 1,000 lines in it, and after you recover from the shock, you can read through it and you can probably at least see everything is in here somewhere. But you're going to have a hard time understanding um, where to find everything in that giant file, right? And then you'll have to start jumping around it and to see what's going on. The difference is you will still have that level of initial confusion with a architected system, but the difference is you will be able to read every file you open. Will you know what each thing connects to? No, because what gets abstracted away in a large system is the connection points.
mm,
So you would say if mouse click do thing, you will at least know that's always true. And the question becomes, what does a mouse click and what is the thing that happens? If you open up a large file, you'll see what the code is, but you won't be able to see where what those things are calling and where they're going as far as the rest of the file goes. It's hard to describe what I mean, but we'll hopefully we'll explain this better when we show actual code
yeah,
examples.
yeah. I think when we get into the code, it'll.
All I really mean is it may feel, and I've done this myself, it may feel like you take a class that was working and you apply a load of architecture to it and you're really proud of yourself. And then you come back to it later and go, oh crap, I actually hate working with the new version more than the old version because the new version has these layers of complexity in architecture and I have to inject 6 things to get the one thing back. But that's not a fault of either refactoring or architecture. That is a misunderstanding of when and where to apply those rules. So, for example, a newer version of the systems I've written is I can write 3 lines of code ish, and I can do a raycast. Or I can use what I do now is I have a class called raycaster. I say raycaster equals new raycaster, raycaster dot check. If succeeded, get me the hit information. And that may seem like, well, why do you have a class for something that takes up 3 lines? Well, because it takes up 3 lines sometimes,
Mhm,
but other times I'm adding against layer mask checks. I'm changing out from whether it's being a mouse position raycast against the screen. Other times I'm doing a viewport raycast, so it's center of the screen. Other times I'm using it as a look detector for some objects raycast from the center of its nose or whatever. Like say for a gun, could be raycast from a pointer or a wand or something. And every single one of those examples uses my same Raycaster class. I just provide a different form of ray, and I provide a different rule set for what constitutes a valid ray or not. And it may sound more complicated to add all this stuff, but here's the thing: that line of code I wrote at the start, Raycaster equals new Raycaster, check. That code will never change.
mm,
So even though the implementation has gotten more complicated because it's got more things to think about, all of that stuff is hidden away from the line of code I write right now, which is I need to do a recast, get the data from it, and do stuff with it. So when I used to do this architecture, I used to make the mistake of adding the complexity in at the layer of abstraction I was at.
mhm,
Meant me creating a raycaster required me to write 10 lines of code, and it used to require two because I'm injecting 50 things. If
mhm,
I'm doing that, I'm not actually extracting anything away. I'm just moving the code around into more verbose points of kind of locations. So refactoring only works if it literally makes the thing you're looking at easier, and that's how it should work, right? It should be easier at the low levels, and the complexity should be extracted out until you inject in the complicated stuff at the higher levels. That's where your dependency of inversion, which we're not going to get into right now,
yeah.
but the point is, like, it should read easier. And the truth is, debugging will always be harder. I think that's probably the one caveat I will always accept is if you're debugging a well architected system, you will have a hard time tracking down who's calling what under what dependency, and there'll be dependency chain issue, and that requires knowledge of the system. And so, admittedly, that will be more difficult, but that trade off is a small one compared to the ability to add a new behavior to a system without having to rewrite 15 classes to support it. So I think it depends where you're willing to pay the price. And as far as I'm concerned, if I write the code well enough, it shouldn't break that often that I need to favor designing my code so that debugging is easier. If that makes any sense, you know?
Yeah, yeah. All right. Well, I think we're hopefully going to see a lot of that when we dive into the code. But before we do that, I saw a couple questions roll through that we can just address, and then we can, yeah, go into the code. Before we do that, though, if you are so inclined, please feel free to invoke that like button. It sounds so lame to say it out loud. I'm trying to think of a better way to say smash that like button, and we came up with invoke. I gotta have
I'm
something.
still disappointed that globally we've all decided to smash the like button. What
Uh,
happened to just click the button, click the like button? I mean, I know that's the YouTube
why do we
phrase,
even
but
need to click the button? You know, it's just like, can't YouTube understand?
yeah.
No, yeah, just like the video if you're enjoying the stream so far. Really appreciate it. And I just saw a link to my latest video roll up in the chat there. So feel free to throw that up in a new tab and check it out after this video, and
Um,
give it a like.
to answer one of the questions in comments is
Mm,
this is so personally I relate to this one. Is how do you start a project when you're afraid that you'll get the architecture wrong?
yeah, yeah, I
I
saw that
have
one.
I have literally unironically spent weeks where I just would go to coffee shops with a piece of paper, writing and rewriting a system I had in mind. I was deadly afraid of writing the first few lines because it wouldn't be right and I wouldn't have the right abstraction layers and I didn't know the exact contracts I needed.
Yeah.
And then I ended up doing nothing with it because you have that analysis paralysis.
Hmm.
But then ages later, I just had a day where I had a beer or two and I was in a good mood. And I said, you know what? I'm just going to write some code. And I did better with that than I did with weeks worth of planning. This isn't to say don't plan, but the general point is there's a reason why they say red green refactor with test driven development. It may seem like well, it may seem one benefit is simply that it's small chunks or whatever, but that helps you. But the main reason I like it is because it gets you out of your own head.
Mm,
Your answer to how do you solve this problem is just solve the problem with
yeah.
whatever you like. You already know the answer, right? If I was writing a system where I had to, when I click the mouse, it fires stuff into the scene. Well, the lines of code I need, mouse click and the spawner and maybe a force thing. I don't know how to write all three of those things. I may not write them in the perfect, abstracted, amazing way I want to, but I know how to write them. So I will write them. So never let this whole concept of refactoring scare you away from ever writing code because that's a dangerous place to be in.
Yeah, yeah.
If you spend as long as we have learning about this stuff, you end up it's permanently in the back of your mind to the point that you end up psyching yourself out. And it takes even more time to learn. You should still go back to writing garbage code at the start. Just do it. Just write the
Yeah,
code.
yeah, yeah.
But here's the important thing. Once you've written the code and it works, that's where you stop writing garbage code and you now look at it and go, right, I've done the first bit, the scary bit, where I had to just figure out how to write it. It works. How do I now make it work and also be good? And that's where you can play with it. That's where you can bit to your source code and then start extracting things and start making it a bit nicer and sort of cleaning things up. And architecture tends to grow out of a system more
Mhm.
so than be placed in advance. Like you're not building shelves and then putting code into it. You are writing code and then moving it out into places that make more sense. And I think when people see design pattern books, like for example, I have it right here. This one, which I highly recommend. Oh,
Yeah, you
you
just
can read
answered
the
you answered another question that rolled
yeah.
through.
But when people see books like that, their mindset is, "Oh, I need to know what all the design patterns are so I can apply them immediately." It's like, no, design patterns are names for patterns that have formed out of the code.
Yeah,
Like someone who's cataloging plants.
yeah.
They're not making plants up and then going out and finding a thing that matches the plant. They are finding the plants that are out there and they're giving them names and saying these have uses, and then people will, use those plants for certain things. So you do it in that order. You start with write your code, you do the things to make it cleaner for what you're currently doing, and you might stop and go, hang on a second, I've just turned this into a factory because that's what I
Yeah,
needed.
yeah.
And then you have a name for it. You have a name for what that's called. And maybe next time you approach a problem and you're scratching your head over what to do, you might go, factory worked well last time. I can apply a factory here. You don't go into it with the intent of, I'll build a factory and then I'll start putting things into my factory. You start with, I need to make a thing. Let's make a prototype. The prototype works. Let's make a factory to make more of this thing. That's the order you approach the solution, right?
And I think a lot of refactoring should be driven by the need to refactor. Meaning, oh, you need to add a new bit of functionality. Well, if it was like an input system and you're supporting keyboard input and you wanted to add, game controller input, instead of adding an if statement, checking for something like your platform or what's plugged in, at that point you might as well just abstract it into a class. I mean, that's a very discrete example, but the idea is I try my best to let requirements drive refactoring,
Mm.
because then otherwise there's just no end to the amount of refactoring you could do. And sometimes the context of your refactoring changes as well. Like you might need to refactor for security purposes. You might need to refactor for optimization purposes. Maybe you get the code running and it's great, and you're really happy with the framework and the architecture and the design patterns you use. But then you run it and you're like, wow, this is terribly optimized. So
You know,
then,
that's a very good point, right?
yeah,
We haven't even talked about that.
yeah,
Sometimes refactoring will regress your architecture. It doesn't
100%.
always mean it's going to make your code more abstracted with more classes. But the beauty of a architected system, you have a boundary line that says,
Hmm.
"Go save this data," and you might have everything behind that saving persistence boundary line could be like a 10-part multi-class
Could be the
code
ugliest
dispatching,
code.
whatever. Yeah, it doesn't matter which way you go. It can either be this horrible wall of stuff, or it could be a nice, neat whatever. But it doesn't matter because the point of the boundary line is you do what you need to do. And if the saving code is horribly lacking performance, then you can just take that piece of code and kind of concede that you have to drop some of the design patterns there, and you have to end up, switching to splitting all of your components out into you know different types of collections. That's a big deal I've found, especially is you have to drop things like link and start using a lot more
Yeah,
verbose hash maps and for loops and being a lot more explicit with your requests and how you keep certain things in memory because you need to be more performant. But you can still do all that behind a boundary line. And
yeah.
that's kind of the beauty of it, right? Is that you've drawn the line to say something deals with saving these items. Or I need to sort, like a great example of this is sorting, I guess. Look
Mm,
at C sharp in general. When you call dot sort, I think it uses a bubble sort by default. I always forget. But there's a million sort algorithms. And you can inject into your code whichever sort algorithm you want. And just the fact that you're using an abstraction layer doesn't make the sort algorithm slow. Makes it slow or fast is what algorithm you're using.
yeah,
But you put the architecture in to give you the freedom to try well architected or fast or slow algorithms. And that's sort of it, right? You draw the lines to tell you where you can change things. You don't have to sort of it's yeah, I guess that's it. You draw the lines and then you can put the code into those lines afterwards, right?
yeah. And we're gonna touch on that too during the refactoring because that was kind of I almost named the video and brought it more to the surface of the video, the idea of drawing boundary lines, system boundaries.
Mm.
But I kind of went with a refactoring a monolithic class because I felt that that would be something that at least it drives to the point where you were refactoring this monolith, and out of it we define our system boundaries. But we'll definitely talk about that a lot when we do the refactoring. So
Yeah.
just sorry, go ahead.
No, I was gonna say, yeah, so just TLDR on that is
Mm,
you don't start with patterns, you write your code, make it work, you refactor to make it better. Having done so, you've now drawn boundary lines. And now the nature of having these separate systems under boundary lines, you can then go back and question how do I want to change each thing behind each boundary line? So that's the general order if you're worried about how to approach that problem. Make it
yeah,
work, tract, split it up, and then from each individual split, you can now have the freedom to go in and redesign inside of each of those areas.
yeah. All right, so just let me scroll up to the top. I just saw the first question we got was, is Dots tutorial coming anytime soon, or has there been any plan for that? Yes, I'm actually going to do a video on Dots this week, and it's going to be high level. So I'm just going to describe what it is, what the state of Dots is today in Unity, maybe talk about where it's headed, and then I'll probably just do like at the end a small portion where I walk through the setup of getting your project ready to go for Dots, and maybe writing something very simple. But I do have plans to do some other dots tutorials in the future. I saw a question. Oh, by the way, yeah, Mitch mentioned a very good point. Drink before programming. There you go. It helps sometimes. Sometimes. There you
I
go.
wholeheartedly agree. I wholeheartedly just remember
Mate.
the bomber peak. Stay within range.
Yeah,
Stay
I
within
know. You don't want to pass over the bomber peak, or else it's all. You wake up the next morning, you look at your code and think, "What is this garbage?" Mate said, with all the classes he's written for his project, it's impossible to remember everything he's written. Module systems. How do you solve this issue? That's an interesting one. I mean, I know professionally, in my place of work, we document everything. It's awful. It's the worst. You can kind of do some. you can do some automated documentation of your code using annotations. I don't like to throw annotations like that into my code unless I'm writing like a public API. Um, but yeah, I don't know. I mean, for
I
that,
have a interesting answer to this question.
okay, I bet your answer is going to be something like don't, because something like that. I would say if you there are ways to document it. I don't know. Well, let's hear what you got to say. I'm curious now.
Well, you're close, 'cause I always like to play the contrarian. Um, I guess let me start with what the kind of what I imagine the impetus to the question is,
Mm.
which is I've written a get random color helper class, or a helper method even. Like I like this, and I'm going to use this a lot, so I build a utilities class or utilities location, and I'm thinking this is great. I can now every time I want to generate random colors, and that's really cool. And then you start using it everywhere. Then you might want to add features to that object, or you split it up into another class, and you start extending it. And what ends up happening is everywhere which originally just wanted to get random colors is now accruing all of the extra features that you've been adding to this helper function or class. And on top of that, you decided you want to change how the random colors are generating, but in this one place. So you've got two options. You either take a risk at refactoring that one helper class and hope it doesn't have negative side effects to the 50 other people using it, or you say, I guess I just won't use the helper in this place.
Mm.
And in all cases, it's frustrating. You're either having this helper that gets out of control and risks that was meant to make your life easier, but is all of a sudden this tendril that's connected to 50 parts of your code base, or you have this constant itch in the back of your head saying, I've already written this somewhere. I already have a get random color. So why do I have to write get random color again here? I know I could just use the other one. They're both unfortunate evil solutions. You have to you have to choose the lesser of two evils. And in my mind, the whole topic we talked about boundary lines, it comes down to understanding the difference between a system that you want to share and a sort of a feature or a small component you want.
Mm.
Now, I find for me, things like get random color, even though they feel like something that could be reused, they aren't. They're
Mm.
just a little. They're a neat name for any other method for two lines of code or something. It isn't a system. It doesn't have moving parts that would require injecting providers of pastel colors or whatever. You might make that. You might make the ultimate color manager, and it takes in providers for color sets and allows you to pick between HDR or whatever. But if it's not that, if it's just to get random color, don't make a separate class for it. Don't make a utilities function, because what'll happen is you'll end up needing that for everything, and it becomes this hidden collaborator because you're going to end up using it across the board for all of your applications. You need a random color, just write get random color. Just write the function again. I know it feels off, but you're not tying to anything else. And in that reuse, the question becomes, well, what's the trade off? And this is the underlying. If you're ever asking yourself, when should I split it up? This comes back to one of my favorite phrases: business rules.
Mm.
If it is something that is an application wide global rule, or it is a rule for your system that says all users must have a email address associated with their account,
Yeah.
that is now a system. That is a validation rule at a business level. That's something you'd want to have injected and managed globally, where you manage this rule.
Yeah.
Get random color. You're not enforcing that it must use this random color. If your intention is to enforce a style sheet that comes from a random color, that's a system. It is an enforced rule. So if something isn't a rule and it is simply a helper, then that helper can be a custom class if you're using it often enough to want that, but it doesn't have to be. And I think when you're asking yourself, am I moving this into the next boundary line? Ask yourself if you need it to. Realistically, rewriting that feature is not that big of a deal, because what you're going to do is you're going to be able to set that as internal,
Mhm.
put it inside of your DLL or your class. Nobody else even needs to know about it. So the question of, oh, but I already wrote this somewhere else, and I'm afraid there might be collisions with other versions of this. Well, no, because something internal on this system generates random colors, and something over here in this other system generates random colors, but they don't need to know that each other generate random colors. That's just part of their internal work. And you can completely separate that idea from the business rules of your application. So the long-winded solution is, if you're finding yourself rewriting stuff or forgetting the fact that you already wrote this feature before, that might be okay, because you might have needed it then in one context and you might need it now in a different context. And unless there's some reason why that needs to be a global rule, you don't need it to be shared. They can be two separate implementations that are just happen to be written very similarly. So don't look at two bits of code that look similar and assume they're the same thing. Because just because they're written the same doesn't mean they don't actually serve completely different purposes. Not everything needs to be extracted out. And that's when you get class explosion that people say refactoring is terrible because I extracted out my color provider and I passed it into everything, and now every single class requires a color provider, even though all it's doing is coloring the log messages. It's like, well, then you messed up. You extracted out something that isn't really a feature that should be extracted, right?
Yeah, yeah, yeah. That and that's like this. It's in lines with over architecting, trying to pull things out, make everything generic. It's tempting. It's very tempting. I did the same thing with a string extension uh, to to wrap all my strings in rich text, and I thought, oh, I could use this everywhere. And honestly, if I ever needed that, it would almost be just as easy to just rewrite it real quick than have to think of the complexity of where do I put this where I can remember it? Where do I store it? Do I put it on my GitHub? Do I put it like into a package and save it on my hard drive? Where do I put that? There, it's silly, but there's like all these little
Mm.
layers of complexity outside of the code itself when you do something like that. And honestly, if it isn't that, if it is that your project is just so large, that it's not about trying to extract some system that you could reuse, but simply that your code has so many things. That's where I think refactoring and architecting your code in a way that it's putting your code into feature folders,
Mhm.
utilizing namespaces. I've never seen, and I've worked on some huge legacy projects. I don't think I've ever seen a project so large that I completely forgot about every piece. I mean, there have definitely been times where I've rewritten something and then realized afterwards, like, oh, I'd already written in this in a util service. But most of the times, even when I discover that, like Jason was saying, an important thing is the business rules of your application, the fundamental. If we're speaking about games, the fundamental rules of your game mechanics. Even in those cases, the worst thing that happened was I just rewrote something I didn't need to, and it took me maybe 10 minutes. Not a big deal. It wasn't like I rewrote a business rule, or worse, I wrote something that broke a business rule that was already established. And I mean, I think if you have the capacity to do that, that's pretty dangerous, and you should think about your code base as a whole, and think about really drawing your system boundaries, again using namespaces and reevaluating what patterns you're using, whatever the case may be. But I mean, I can't see in my mind's eye a code base that's that large and messy, that I would accidentally rewrite code and break a business rule. And that's
Yeah,
really what matters.
and if you want an example of having too many things and you want to solve the problem of too much stuff in your code, we talked before about boundary lines, right? Your application is just a series of boundary lines, and one of the best examples for this would be an API.
Hmm.
If you ever wrote an API, it's got a lot of moving parts. You've got a controllers that take the routing endpoints that get fed into some kind of logic that validates and coordinates stuff that eventually gets sent to some kind of persistence layer, which will call some queries, which end up getting some data from some persistence repository or whatever, and it ends up using mappers to map objects back and forth. And there's a lot of things. So, for example, the route of a get users endpoint will go through a controller, which passes in a request model, which gets mapped to some kind of query object, which gets passed to some sort of mediating system, which will call some kind of repository, some kind of service actually, which will then call some kind of repository, which will then contact the actual implementation of the repository, which will use a mapper to map from the DTO from the database, and that's haven't even covered validation, right? You
Hmm.
can then add validation layers and authorization layers on top of that. There's a lot of moving parts,
Hmm.
and you can often look at that and go, "There's too much stuff. How do I figure this out?" Well, for starters, there's three layers. There's persistent stuff. There's the API front level stuff, and there's a controller layer. So you basically got three things: stuff that does saving things, stuff that does the actual validation slash routing stuff around, and then there's the stuff that is the public facing endpoints of the API. So you start with those three directories, with those three. In my case, I use class libraries. If I ever need to do database ish stuff, I go to the persistence project. That's the first half. I've already taken. It's an funny thing is, oh, funny thing is, this is a sorting problem, like real life sorting. If you're writing a sort,
Mm.
want to divide by areas. You divide your code into three different code bases, which is persistence and front end and controller, and then from there you divide further. So if you've got too much stuff going on, just draw a boundary line around a certain area. That makes sense.
Yeah, definitely. All right. Jason's getting his video back, by the way. We saw that it popped out.
Hmm.
I just saw one last question. This is the last one I want to answer, but keep them coming. If anything, we can try to answer them after we do the code refactoring. Um, Vic Peck says that he recently saw the TDD tutorial and was great. It's slowing him down, but he's starting to lose faith. So basically, what I will say about that, test-driven development, you know, it's not an end-all be-all. It's a development process, and you can use it on certain things. I don't use it on everything. What I would use it on are things that are maybe maybe things that require algorithms that I just can't. I'm struggling to plan out. I'm struggling to see how the implementation would look. Maybe it's something new that I've never worked with before. In those cases, I would probably use TDD to help drive the code that comes out of that. Um, and I would let that slow me down because that's the compromise I would make. Uh, Also, testing in game development as well. I think there's a tendency to want to test every single aspect to get 100% code coverage. And in Unity, testing model behaviors is a huge pain because obviously you have to go in, you have to do, um, you have to create objects in your scene. You're doing that from the code, from your test. That's slow. And unit tests in general, they're supposed to be super fast. Like an entire test suite should not run, it should not take more than a couple seconds to run in your best case scenario. So, when you're doing things like you're having this scene in memory and you're creating all sorts of objects and it's really slowing down, that is actually that's a red flag. So, realistically, you should be trying to code, and we talked about this just now when we were discussing this previous discussion. You need to first worry about your business rules, the fundamental rules of your game. So one I always go back to because it's always like for some reason the forefront of my mind is like a health system. You might have a fundamental rule that any player or enemy or any object or anything in your game that has health can never go below zero. That's just a fundamental thing that you want to validate against in your game. So let's say you abstract health into this health class that everything reuses. On that class, you might have a method called damage or maybe set health. And you want to just write tests that say when damage is called, no matter how many times damage is called, with whatever number that's passed in, a negative health can never be represented as a negative number in your system. That's something you'd write a test for. Now, if you have something like there's a trigger in your scene, and then when the player walks over it, they get damaged, I would not suggest writing a test to ensure that the trigger goes off and your player gets damaged because that is something that's built into Unity. Unity has their on trigger down Unity event. They should be testing that, not you. As if you have an object that has a trigger and a collider, and you have a player that has some logic that reacts to that trigger going off, I would suggest not testing that because that is a Unity thing that they should be validating that works, and you should have a certain trust in Unity as a framework to run that code. However, like I said, if the business rule is that your player's health can never go below zero, then as long as you have the test on your health class, the unit test on your health class, ensuring that when dot damage is called, no matter what's passed in and no matter what the value of health is, it doesn't go below zero, then you've covered everything you need to cover for your particular game. So that's just sort of like a mindset that you just kind of have to go into, not chasing after 100% code coverage,
Mm.
but chasing after ensuring that the fundamental aspects that are particular to your specific game are never broken. Those rules are never broken.
Yeah, you test the code you write, not the test that you're reliant on.
Hmm.
Um, and I think the best metaphor I can come up with for that, if you want to test if a TV remote control works, you don't start at if person presses button, does the infrared signal hit computer or hit TV and channel changes? You check if infrared signal hits TV, then channel changes. Because the person might fall asleep, and that shouldn't impact the ability for your test of your infrared signal. You know what I mean? Like if you capture components that are outside your control, you're reliant on. third party things that could break what your system does. So in essence, literally what Charles was saying is you don't test if trigger pressed or if on collider box do this. You write the code that says um, fire, and you put that fire code into the if trigger pressed fire, and then you can test the fire code by manually triggering it and seeing what it does.
Mhm.
And so the fact that something else activates it is incidental. That's
Mhm.
nothing to do with your code. And likewise, if you think about an API that provides information, if you've ever written an SDK layer for an API, you'll know there's like a million things that can go wrong. There are HTTP response codes. You can get a 500 because the error gets thrown. You can get a 400 because the response is bad. Get 401 because I think 401 is the
Authorize.
unauthorized. Yeah,
Yeah.
and then there's other ones for forbidden, and there's other ones,
Mhm.
and that's
302.
just yeah, and they're just the ones that are response codes that go wrong. We haven't even talked about what if you get the model back in a format you didn't expect and
Oh,
things go
yeah.
wrong, and
Yeah.
what if
Validation errors.
you have the wrong accept header, so you get XML instead of JSON. Now, why am
Uh-huh.
I going through this whole rabbit hole? Because if I have a system that says get me animals in the zoo, that might be going to an API and going through this entire rat's nest of issues and bugs and coordination and whatever.
Mhm.
And I don't need my test to have to check, did I get it forbidden because the authorization I applied when I called the zoo database didn't apply? No, none of that's relevant to the get me animals in zoo function. I am testing whether or not, when asked for animals, and I expect if I give it a mock or a substitute that provides me two animals, does the rest of my code know how to respond to those two animals? No?
Yeah. All right, so I think we're at a good place here. I saw some more questions roll through, but we're going to jump into the refactoring. Now, for those of you who have not seen my latest video, I'm going to drop a link in the chat. And the reason I'm doing that is because the code we're looking at here is from my video that I posted on Sunday. If you haven't seen it already, no worries. Just open it up in a new tab and check it out later. But I just wanted to walk through it live and just give the opportunity to sort of open it up for discussion. Or if not, we can just walk through it like I did in the video, and we can see this sort of as a live tutorial. So Jason's getting his camera ready. In the meantime, we'll just pop over to the code here. So basically, what we're looking at here is a game controller, and if you saw the video, forgive me, I'm just going to go through it real quick. Um, so we're looking at this game controller, and this game controller it controls a couple different aspects of our game. And so the game is very simple. The gameplay is simply it's a VR game where you have your controller. If you pull the trigger on the controller, it shoots. So it's very the most basic implementation of first person shooting there could possibly be. And if we look through the code, we can sort of see that here. Um, in fact, I still have some things that I've refactored. Let me back out of that real quick. Let me just inline this. Um, okay, so as we can see here, first thing it does is it's going to check this, and this is an update, right? So this is running every frame it's going to check. First thing it does is it checks this OVR input, which is part of the Oculus VR library. It just says, hey, look, I'm going to check if the primary index trigger, I'm going to check if it's down. So every time I pull, I got one right here actually. Every time I pull the trigger, where is it? It's going to come into this is going to evaluate as true, and it's going to pop into this method here. Next thing it's going to do is it's going to instantiate a bullet based off of a bullet prefab that's passed in, or rather is actually exposed on a serialized field. Jason's like, I have no idea what's happening. Let me know what I can do. Sorry. All right, so it's going to instantiate this bullet using the bullet prefab, and it's going to use this controller anchor, which again is just part of the Oculus VR, one of the prefabs. Here he is. I can't hear
So it
him.
seems my camera's having a case of the Mondays. So I'm obviously very both blurry and also oddly positioned again. So what can I say? It's one of those days.
Yeah, what are you gonna do? It's Monday. You got to get on a Balmer Peak. You're on the bottom end of it right now.
Yeah. See, I showed you that whiskey, but I haven't actually had any yet. So that's probably the problem.
It looks like your camera's had some whiskey, actually.
Yeah, yeah. Give me a second. I'll fix the bloody blur next.
All right, so just going over the code here. So in this update method, you pull the trigger, get down is true. It's gonna instantiate a bullet based off of the bullet prefab. It's gonna anchor this bullet to the controller anchor, which is wherever it is in 3D space. Then it's going to just apply some velocity to the bullet's rigid body. That's going to get that bullet flying out. And then we have this ammo, which is a float, this ammo field. That is how much ammo the player currently have. It decrements it, so we take a bullet out of there. And then it has this coroutine that just manages the lifestyle of the life cycle of the lifestyle of the bullet. That's funny. The life cycle of the bullet, meaning it's going to destroy it after X number of seconds. So it's just not, sitting in the scene. Finally, we've got ammo text, which is a label that's in world space, and it's just displaying the label. And lastly, the last thing we can see here is we've got this vibrate controller coroutine. And what it does is it just turns on vibration on the controller, waits for a third of a second, and then just stops the vibration. So you get a little buzz, which is kind of nice feedback. Um, so that's the code. And now the point we make in the video, or my trusty assistant Barles, is what Jason has named him, Charles Barles. I call him
Yeah, I'm
Barley.
gonna endlessly take credit for that. It's fantastic.
I call him Barley because I think that sounds actually kind of cool because it's like well, whatever. But Barles, he's like, I look at this class and something seems off, right? And you might be looking at this class and maybe you think, it looks good to me. Personally, I look at this class and there's sort of a code smell. There is for me. I look at it and maybe it's experience, but I think this class is definitely doing a lot. And it's only 47 lines of code. So, in a prototypical phase of your project, you might think, this is fine. But like I said earlier, if you're going to refactor, I try to let requirements drive that refactoring. So we're going to refactor this whole thing. But let's just pretend we have some requirements. Let's pretend here that we're using Oculus VR, but we want to support Stream VR. Or maybe,
Well, I guess that if we're talking about why you're doing this, right? I think
right,
a really
okay.
good example for this is if you just scroll down to both the update and the method below it are both in view.
Hmm.
So the first comment I would say is imagine hypothetically down the line someone says we don't want to use OVR anymore, we want to use OpenVR or we want to use SteamVR. Now, without even like, if you just unfocus your eyes and look vaguely at it, you'll see immediately there's multiple words on the screen hovering that kind of indicate these are all things that reference that particular uh, that particular dependency,
Yeah.
and that's that sort of code smell that Charles is sort of he innately understands it at that level because you see it often enough in code like this. You have this kind of icky feeling in the back of your mind that says this this thing, if I change it, I have to go through my entire code base and change it in every single one of these places. And so the question is, when should you refactor and what's the point? Well, that's a very good indicator.
Hmm.
How much of my code is going to have to fundamentally be rewritten to support the fact that this will change? And likewise, right now, the shooting code currently it's just shooting. So right now we can just put a big blanket over it and say shoot stuff.
Yeah.
And maybe if there was shooting and we were adding particular implementation to that, that would be like, hang on a second, how many times am I referencing this implementation? And then that might need more refactoring. Right now, there are other dependencies, and you can, as we said, you can go down this infinite rabbit hole of, turtles all the way down for refactoring. But the things that matter right now is where's the biggest risk and things likely to change together. And right now, the OVR input is like this giant.
Yeah.
It's literally like littering itself throughout your code, and that's like, hang on a second, but it's one dependency. And I turn all of these references into one thing that just says OVR stuff. And we'll figure that out how we go from that later. And so
Yeah.
now I guess Charles will show you what his approach to that is.
And it's funny, like things like TMP, how they it's and even OVR, like I usually like hate that. Like I don't like to put what I'm saying is I like Pascal case. I like naming classes things that are human readable, so to speak. And I see OVR input and it's like bleh, like so I actually appreciate when I see like OVR input, TMP text. That underscore kills me. But it makes it very clear that I am leveraging some other framework. And
Mm.
to me, that also helps. And it's a reason why I recommend using things like namespaces, because those are those things where that explicit, you know, I guess it shows you
Yeah, that
explicitly.
dependency reference, it shows you, like, what am I collaborating with? What are the kind
Exactly.
of hidden dependencies? Yeah.
So that's very nice. I'm just gonna touch on something that I just saw in the chat. Robert, I think, no, Shattered Prism asked about.
Oh, the string interpolation?
Yeah,
Yeah.
it was answered in the chat, but I thought I'd throw it up. The dollar sign string interpolation is a feature of C sharp. So if you put a dollar sign in front of a text string, you can go ahead and add brackets, curly brackets, and you can put variables. So you might say mo text, dot tech, dot text, no, not dot transform, dot text, and that will print the variable. It'll actually interpolate the or get the value and display it as a string. So that's just what that is. It's not a feature of TMP or Text Mesh Pro. All
Yeah.
right, so we have a requirement. Well, let's say we wanna get this out of our code, OVR input, because we want to use something else, Steam VR, or maybe not even a VR solution. So what we can do is we can isolate and look for all the references to OVR input. We can see, as Jason mentioned, there's two. There's this if statement, and then we've got this vibrate controller coroutine. So um, what I'm when I'm refactoring something, the first thing I want to do is try to extract all of the code that I'm going to move somewhere else into another class, try to extract those into individual methods because
Yeah, 100%, yeah.
it makes it easier when I make the class. All I have to do is just reference now the method and move the method over to the other class.
And
So,
that's the other thing too is I usually find that helps on multiple axes because not only does it help in terms of, like, minimizing the impact of the problem, but it also forces you to ask yourself if these things are related. You can give it a name. You can start to say, "Oh, these things have names now that are a descriptor of what this does," and
mhm,
it sort of it helps you define what those classes should be based on what their names of the functions are. And even separate from this particular question of refactoring out this entire OBR reference, I like to do that with my if statements in general.
mhm,
I don't like this
100%.
idea on line 22 where it says if thing dot get down some other whatever. That should just be if clicked thing, if button pressed, if whatever thing, and then something else decides what that is. And I think that this is a good example of extracting out that feature.
Yeah. Yeah. So yeah, the idea of extracting, it makes you think. Like you're here and you're like, okay, I want to extract this into a method because I don't want to have to conceptualize what OVR input dot get down is. Even though
Mm.
it might be obvious to me right now, it might not be obvious to someone who has never worked with OVR input. They might get down, they have to go through it, they have to read it. What is that?
And as
So,
somebody who has worked with the OVR get down before, here's a fun fact. There's multiple variants of that. There's get down, which is using primary index trigger, is a virtual mask for either hand. But there's also get button raw, which will provide you with the device mapped indexed one, and you can provide based on the controller input you're using. But there's also a third kind. So without getting into details, there's three different ways to define which button or trigger on a VR device purely with the Oculus integration for it. And all three of those can be confusing and different. We haven't even gotten to the point that you might want to swap it out for an abstraction layer that's different, that's using anything from Rewired to OpenVR to even the new XR solution that Unity is providing. So
yeah.
rather than going, which one is this using? Which button is it referencing? What is going on here? If that was just if trigger, then you can figure it out later. What is left trigger down? Something. It does
Yeah.
a thing that detects whatever the left trigger is.
Yeah, exactly. Did I just pull this onto a property instead of a method?
You did, but
That's fine.
that's fine. Works. Yeah, I think it looks
I'm
fine.
gonna change the is
I was gonna
trigger
say get
down
rid of the
too.
get as well.
Yeah,
Yeah,
yeah.
exactly.
I'll make it change that to is.
While you're doing that, I'll answer one of the questions in the chat. Someone asked, "What is fixed update for?"
Oh,
Well,
thank you for the super chat, by the way, Fahad. You're gonna get a
um,
super answer now. That was lame.
I
Sorry.
accidentally forgot. Um, so without getting too into it, the reason for an update loop is an update loop is a constant tick of what's going on while your application is running. And it's like any other method you'd write. You'd write a method called do thing. And the question becomes, how often do I call my do thing method? And if you've got something like a character's position that's moving across the screen, and you add +1 every time do thing is called, that will happen relative to the speed at which you call it. So what I mean by that is if you call that method 50 times in a second, your character will move 50 steps. If you call that method 200 times in a second, that character will move 200 steps. So you really want to make sure that you're calling it the right amount of times. Now the problem is update is not frame dependent. So
Mm.
update, depending on how good your computer is, will call at different rates, different speeds. And so you end up having to use this thing called time.delta time, which tells you how much time has passed between frames. So if you multiply a value by time.delta time, it will normalize it so it happens over the lifetime of that frame. So for example, I take the number one and I multiply one by time.delta time. That value will be go from 0 to 1 over 1 second. So if I take a value and I add time.delta time, that will be 1/1 second. So effectively, what I'm getting at is there is a number of there's a time that travels between frame time, and you don't know what that is when you run your update loop. But physics runs at a different rate than the rest of your game because physics needs reliability. So what you do instead is for fixed update runs unlike the normal update, which is dependent on how fast your computer is. Fixed update will run with a constant differential between frames. So that's 0.002, I think. So effectively, you'll guarantee that each step is equidistant between them, and that's great for physics. It means physics can reliably calculate and move things smoothly. But it's not great for things like input. If you do your input inside of a fixed update, you can literally miss the frame at which they press the button because they could press in between the update polling rate of the fixed update. So, long story short, fixed update is used when you need to have something persistently, cleanly applying at the same rate. And that's usually physics, because physics needs to calculate stuff using time as an actual parameter.
Yeah.
For things that are more about reacting, you want that to happen in real time, but also count for frame differences. And that's where you would say, um, check the inputs the user gave you, and then move something, but multiply it by the delta
Time
time
dot delta, yeah.
so that it averages out to be fair. And it doesn't matter how long. Like it might take zero point 0.2 of a second for one frame to travel, but the next one might take zero point 0.4 because it's never going to be even, right? Depending on how much work your computer is doing, the frame rate is constantly going up and down. So you kind of want that to be averaged out, but it doesn't matter if there's a larger jump one step to the other. But in physics, something was to move twice as much in one step than the next, that can massively mess with your physics calculations. So it's better to keep that stuff happening equal, even if you miss frames. You don't mind if it's not happening flawlessly every single frame. It's more important that it happens consistently.
Mhm.
And there's other stuff too where you can actually change that rate value. Like you can make it much smaller if you need a much larger much faster physics calculations. But yeah, but you don't. By default, providing if you do anything to do with adding forces and messing with velocity, do it in fixed update. You're doing input, do it in update. There you go. There's your long-winded answer to that question.
I was like, that was a super answer. Thanks. All right. All right. So let's continue here with the refactoring. So we refactored the idea of is trigger down. Now you might rename that is player firing. Right now is trigger down works. We can refactor that later. The idea is whatever the trigger is, whether that's coming from Steam VR, OVR input, maybe trigger is I clicked my mouse button, depending on how I'm running this. If it's down, I'm gonna shoot. I'm gonna fire here. So the next thing I'll refactor is because again we're trying to get this OVR input, this input dependent code out of this class, so we can change it to another type of input. Is this vibrate controller coroutine? And what I'm gonna do is I'm just gonna drop it into a method called vibrate controller because right now I don't really this game controller doesn't need to know if this is some sort of asynchronous thing that runs over multiple frames or not. It just needs to know I want to vibrate the controller. However that needs to happen, just go ahead and do it. Now a little tip about how I'm extracting these methods. I'm making sure to extract them into public methods just because I know I'm going to move them to another class and they're going to need to be publicly accessible when I call them. So let me just move this down. So here you can see these three classes now represent what we have as far as input goes in this game
Mm.
controller.
Now,
Uh,
I will say one thing here as a small pause
hmm,
is this is interesting relative to a question someone said earlier, which is if you're worried about getting the right contract. I can
hmm,
say from experience doing this, the vibrate controller function will at some time end up taking a strength value as a float.
mhm,
You will want to be able to control how much vibration and maybe even the duration as two parameters for whatever this abstract system is.
right.
But we don't need that now. You just need to move out the dependency. And so the question is, what if I don't make the right contract? So what? Make the one you need right now. And then later on, when the time comes that we're deciding that we want to control that, will make a method for it. You may even refactor the current one, and then later on, future implementations will implement that new version. So I wouldn't worry. At this stage, it doesn't need to have it, but I want to point out the fact that you might be in that moment where you're like, "Oh no, I should probably add all these parameters that might need to." Don't do it because you end up going down a rabbit hole of designing a contract based around theoretical features. Right now, we just need it to be extracted out. We'll figure the rest out later.
Yeah. So what we're good, and that's a good point because, and I even mentioned with like is trigger down. I don't know if that's the right name. That might actually be confusing later on if if I start
What if it's a
adding
grip or something instead of a trigger? Like that's a
right.
common one. You might change it to the grip on the controller versus the trigger,
So I
but
might
that
want to
doesn't
name it
matter.
something like is player firing or is fire input. I don't know. But it just genericizing it even at a higher level, abstracting it at a higher level. But right now this works. We've got great tools to refactor names of methods.
And if
So
you're using source control, you can safely at some point
mhm,
just go on a major name changing thing. I do this all the time. I'll give it some name. I'll get halfway through the project and go, no, no, better name now, and I'll just rename things because I now have a better understanding of what it does.
yeah.
So feel free to name it something and then come back later and change it. Yeah.
Yeah. So now we're at this point where we can go ahead and move this out into another class. And I probably shouldn't do this live, but I was curious to know if there's a way I can actually grab this and use Writer to actually pull this into a class, like extract class. There's extract super class. I don't want to do that. Abstract class to interface. That's probably for this particular class.
Hmm.
So I don't think so. There's this method, or there's a method of refactoring called move, and I'll probably be able to show it later, but I don't think I can do it in this case. Anyway, I'm just going to create a new class, or rather, a new mono behavior,
And I think
and
last time I tried to do this, you could move one method into its own class, and then you can cut the rest or move them to that other class once it's
yeah,
created. But I don't think you can natively grab like a bunch of methods and say make a class out of this.
yeah. There is a move functionality, and I've only gotten into work like in some cases, and it's never really
Mm.
been good and clean. But we'll see. We'll see if we can get it to work later. All right, so let's just call this. In the video I called it input handler. Maybe there's a better word for it. Input controller, input manager, input
Well, as per what
system.
we said earlier, I don't care. We can rename it
Yeah,
later if we have to.
doesn't matter. Oh, and the other thing I did was in the video I wanted to leverage namespaces here, so I put it into a namespace called UI, or rather dot input. So we'll go ahead and do that. And I'm just going to move, let's see, I have to move it to the input folder. So that's just writers suggesting some things. Basically, the convention, you don't have to do this. The convention I would highly recommend is you would have your namespaces match your folders. So if I'm going to put the global namespace of this project is scripts.start here, because if you go to my Patreon, you can actually download this project and the folder start here. The namespace start here is where you would start, following the video. And then if you go to the refactored namespace, you'll see the actual finished product. But basically, the base namespaces start here, and then dot input. That's going to correspond to a folder called input. So now that we have that, what we can do is we can just copy and paste all of these into that input handler class. So go ahead and do that. Copy paste, and make sure I have all of the right using statements. Oop, not that one. It always does that. It defaults to system.collections.generic instead of
Hey, remember when it used to always default to the boo
yes,
collection?
bool. Oh my
Ah,
gosh, so
horrible.
annoying. All right, so now that we have that, we can go ahead and add a new field. Make this a serialized field just to stick to the Unity convention. We can drag it in. We can figure out later
Ooh,
how.
S field. I've actually never used that one.
Oh
Interesting.
yeah, that's a great one.
Oh, by the way, Jason over at Unity3D College pointed out one to me: Shift Control Alt and up and down. That's one I didn't know existed that I now
Oh,
use
to move
literally
things
every
around.
day. Yeah, you don't
Mine's
even need to
just
highlight. You don't even need to highlight it. You just
like
click on
this.
the name. Yeah, but yeah, exactly. You don't even need to highlight it. If you just click on the word update and then do that, it'll move the update function by
Hmm.
each logical chunk.
Okay, that's interesting because it
Yeah.
did it actually move? Oh yeah, yeah. All right, cool.
It moves a logical function or field
Yeah.
to around other logical functions,
Yeah.
which means if you want to like I do, which we had this discussion before, move the constructor to the bottom. I
Hmm.
like to do that. It's much easier for me to do that by just Control Shift Alt and pressing down.
Hmm. Yeah, it's nice. I love those little power user tools.
Mm.
All right, so now we've got this input handler class. It's got two public functions. That's the interface, vibrate controller, and is trigger down. So at this point, we can go ahead and replace these calls. Input handler dot is trigger down which is why is it complaining?
Uh,
Did I make it private or something?
is it private?
Public?
No, it looks fine to me. Maybe it's just not going. Oh, yeah, that should be fine because it's an accessor, not a.
Oh, I wonder if it pulled it from for some reason it pulled it from the refactored.
Oh, right. So it's the other version, which is a method and not a. Got it.
Yeah,
Yeah,
yeah.
makes sense.
Or it doesn't even exist because I called it. Yeah, I called it get, and so we're just gonna update this. My bad. Don't worry about that. Sorry, don't let that be confusing. Basically, I pulled from the wrong namespace.
The beauty of namespaces, we've got multiple versions, and yet it's not causing issues normally, providing we're paying attention.
Yeah, providing we're paying attention. So then we'll do the same for this input handler dot get vibrate
Yeah.
controller, and then now you can see that these are two grayed out. These are both grayed out, meaning they're not being used anymore. Writers using that to signify that they're not being used, and we can remove that. And now we've moved all of that functionality, that responsibility that game controller had to decide how input is handled. Now it no longer has that responsibility. It just takes an input handler, and however that input handler wants to implement input handling, in our case, it's OBR using Oculus, it can do that. And then game controller doesn't need to know. So that's a simple refactoring. I guess we could just go through. What do you think, Jason? You want to just go through the other ones that I did in the video?
Yeah, I'd
Yeah.
say I wouldn't even like go through them in the same detail. I would just demonstrate them, and then we'll talk about the end result of it and what the benefits are. I would just
Beautiful.
go ham and do it quickly, I guess.
All right,
Um,
so the ammo text is another one. We don't need to be concerned about like how we're displaying things on the UI. Right now, we're very dependent on Text Mesh Pro, but I might want to just print it, you know. So I'll go ahead and make a new class here, and we're gonna call this new or mono behavior, which is a class, but whatever. We're gonna call this UI. Oh, we're gonna call this UI. Put it in the UI folder, and we're just gonna call this, I don't know, ammo label. I think is what I called it in the video. So it's just a whole class to represent what the ammo label is and how it's represented.
as
And
an unrelated note, just when we're talking about, I know you don't like the TMP underscore.
yeah,
I find that there's certain classes I use purely as view presenters, and you wouldn't like it, but I preface them all with UI underscore
huh,
because I very clearly define things that I consider non-logical components that are kind of almost free to play with from a design perspective that don't have any negative business rule impact. So just a fun side note, I personally use that naming convention when it refers to things that are UI exclusive.
yeah. I mean, hey. You've seen the progression. I think if you've been following these live streams, I am actually it's growing on me to do things like that.
Yeah.
It's actually growing on me. So smash that like button. All right. So next, what I did was, you might have noticed that I pulled this amount. I mean, this ammo. I pulled it into a local variable called amount. That's just going to
Yeah.
help me when I do the extraction. So I'm going to take this ammo.text equals amount. I'm going to pull that into a method, and that way, again, like pulling it out into the other class is going to be is going to make it easier. So I don't know what to call this. I called it update ammo label, which is totally maybe I'll just say update text. How about that?
Mm.
I think that's better. So now we've
I,
got
I
this.
I usually just again purely from naming things is I usually just call it set because
Mm,
you're basically the implication is it is an AML label and you are setting the text on it.
yeah,
Update implies unit of work being developed as opposed to like assigning a new value.
I like
But
that.
it's entirely arbitrary though.
I could use it. I could probably just use a setter too to like a dot text that I expose and it put but whatever. We won't go.
Yeah,
That'll be
exactly.
in the bonus Patreon content. All right, so now we've got this update text method. So I'm going to copy it and I'm going to drop it into the label, ammo label class, which is great. And again, harkens back to what Jason was saying earlier that I might get it wrong the first time, but it's okay. I can update that as I go. So we're going to say ammo label. Make sure I get the right one. The start UI, ammo label. Okay. And then I'll replace all these calls to my local update text method to ammo label dot update text, which is a huge mouthful. I probably made it private. That's why it's complaining.
Well, if you actually click on the update text, you can probably from there the writer will suggest
Yeah,
publicizing it.
make it.
I
So we're
guess.
gonna make that public. All
Yeah.
right. So now we've extracted that, and I can go ahead and remove this ammo text serialized field that I no longer need to reference. I'll let someone else figure out what that is.
Hmm.
Um, Lastly, we're going to take this logic here, and this is the shooting logic. So ammo, generating the bullet. Go ahead and pull that into a method called fire. So I'm going to do extract method, call this fire, and again, I'm going to make it public. Forgot to do that last time. Now, what happened here? Did I miss the bullet lifecycle? Looks like I missed that, so I'm just going to. Oh, interesting. Here, I think I did that too fast. Fire. Yeah, here we go. There you go. All right, so I'll make this public. It should drop all that into there you go, a public fire method. Again, we'll make one more class, one more model behavior based class, and we're going to put it into a feature folder. I'm going to call it shooting, and I'm going to put it into a class called gun. So we'll go ahead and do that. Then, just like before, I'm going to copy this fire method, paste it into the gun class. It's public. Make sure, oh, I'm going to actually now have to pull in all those serialized fields that we had here because that's going to be the responsibility of the gun class to figure out
Hmm?
what the prefab is, what it's doing. Oh, I also have to pull in bullet lifecycle, managing its own bullet lifecycle, not a responsibility that the game controller should be concerned with. Okay, now all I got to do is just add a new serialized field. I haven't looked at the chat, so if there's anything that came through, if I'm going too fast, let me know, Jason.
No, it's good. 'Cause I think this is again. There is literally a video where
Yeah,
Oz
I
does
go
this in
through all
slow
this.
motion. If you want to go to, we're just getting to a point so we can demonstrate it, kind of a few things about it.
Right, exactly. So I'm gonna call gun.fire. I'm gonna remove all of these methods that I no longer need, and remove all of these serialized
Right.
fields that I no longer. Oh, there was actually one more thing that I had to do, and that is I need to actually expose ammo. So I'm just gonna do a public field, a property rather, and it's gonna be a float called ammo, uppercase ammo, because that's public, and I'll just use a expression. What is this body expression to expose
Yeah, expression body member.
expression body. And then now I can go ahead and when I'm updating the ammo label, I can actually call guns ammo. So gun, gun dot.
A good point is someone mentioned that should probably be in start, not a wait. Small, small thing.
There you go. You know, you might not get it right the first time. And then we're good. So now I can remove this and look how beautiful this little class is.
Now, this is where I wanted to get to
It's
because
the
there's a lot of
meat and
interesting
potatoes.
things to talk about from here. This is where the video left you off as like you know, here's something you should do, and that's a great point. The video gets you to where we need to be, but I think now it's a good point to highlight a discussion about why did we bother? What is the point of it? And to show you the benefits you get from doing this.
Mm.
So, first thing, if someone was to ask us, what is the logic for our game? What does our game do? We can now literally describe it as a pseudocode algorithm. What do
Mm.
I mean by that? Someone asks you, what does it do? Well, if trigger's down, my gun fires, I update the ammo label, and the controller vibrates. I can see it. I can see every single thing that my application does in a readable, structured manner in the update loop.
Yeah.
And it's that's step one. We can actually see what the code, what the actual business rule is. Trigger pressed, fire gun, update label. That's what the actual rule is. But more importantly, not only have we moved all of the dependencies, we've made it so that this class doesn't actually know what the dependencies are. So if you were to ask somebody and give them that chunk of code and say, what am I using to trigger the press and what am I firing? They can't answer that question
Yeah.
because it's not here.
Yeah.
That's what we want. We don't want it to be here because we want the freedom to make that decision change later and it not impact the actual business rule or the algorithm that we've written. So I thought that's something we could actually do if you wanted, Charles.
Let's do it.
We could make a different variant for one or two of these to prove the point.
Okay, I like that. Do you want to go through and extract interfaces as well, so that we can? Because right now these are all just classes. You gonna go to the trouble of extracting the
Mm.
iGun interface and all that, or you just want to replace this?
No, I just think an abstract base class is fine because again, I don't want to get into massive, complicated stuff. I just want to say, if you take, I think input's probably the easiest one because it's got
All right, let's do input.
or label. Let's do label. Actually, it's even easier. Let's go
We
with the
can
UI.
print it to the UI or to the
Yeah,
debug.
exactly. Yeah. So let's just change this from being. Let's give it a new a base class of something else. Yeah, call that abstract and then call it ammo label, and then we'll make a text mesh pro ammo label and a console ammo label.
All right, cool. Yeah, all right. So basically, we're going to take this, and I should probably actually be able to You want to make this? Do you want to make this virtual or make it abstract? Because we could have like a
I would say, I guess it comes down to the yeah. I
yeah,
would say in this instance, because I don't want TextBase Pro in this, so it's going to have to be.
yeah. We're gonna have to
I
move
would say
that
make
out.
it abstract. Yeah, because we're
Okay,
going to be
okay.
moving that out anyway. So let's.
All right. So we'll make this abstract. Remove this. So
By the way,
now,
there's a debate in the chat about whether you should be updating it in awake or start, and so I'm going to put my foot on the specifically on the case of start. The reason being, if you look at the lifecycle chart for how Unity manages all of your scripts, the overall is every single awake is called before the first start, and the reason for that is the point of awake is to do your get components, is to grab all of the references to the other things you need and hook those things up. Start represents the first actionable step of your application. And so things which initialize would be initialized on start. That way, anything that needs to be hooked up is done in awake. In other words, grab all references, and then all actions that need to be done on those entities are done in start. So awake is to get things, start is to do your initialization on the things you have gotten. So it should actually be start, in my opinion. Just to put a caveat on that.
all right. So now we're back to base here. We've got
Yep.
the ammo label, which is abstract, and we've implemented TMP ammo label. And it just like before, it's just an implementation, which means that we can pass that into this ammo label field if we wanted to.
Yep.
But we're gonna go ahead and implement another one. So
Hmm.
I'm just gonna come here and I'm just gonna say create derived type. And we're gonna call this debug ammo label. Which it's interesting now. The more I'm implementing this, I'm seeing where ammo label is just such a weird name for it, and I'm already thinking of ways to change that. So in
Yeah,
this case, whatever. It's just something to think about. I mean, it gets the juices flowing. You know what I mean?
it does, yeah. Like I'd say I think it's fine. It's more for I guess though again, like imagine if it was UI underscore ammo label, then but again, ammo labels implying it's a label. I guess it's not end of the world. It's not one of those big things that's too much of a worry, right?
Yeah, yeah. I almost want to do the same for input handler because now I know when I go to test this, I'm gonna have to have my VR headset on.
Yeah, I think you should, but first I want to do one other thing. Can we actually move those can we actually go to the inspector and drag in two variants? I know we can't run it 'cause it's a VR application and you don't have to get the whole headset out, just to
Yeah,
demonstrate that you can replace either instance.
right.
Um,
So we'll go ahead and create one is gonna be OVR input handler. And then I'm gonna create another one called not input handler. What am I talking about? It's TMP ammo label,
yeah.
which I should actually probably put that on the actual ammo label itself. Maybe I don't know. I'll keep it out here so we can.
Yeah, just so we can see it.
It's
It's
easier
fine.
to see. Yeah. All right, and then I'm gonna call this debug ammo label. All right, we'll drag them next to each other. What the heck is this thing? And then so here I can put the TMP ammo.
You have to move it out to its own object. I don't think Unity likes that it's
You're absolutely right. So I got to put this into its own class, both of them into their own class files. Does not like that. All right, good. Come on. Move to tmp.cs. Go ahead. All right, now that those are in their own class files, Unity's going to be okay with that now. So we'll go ahead and tmp ammo. There it is.
mhm,
And then I'll have to drag my text. So now you can see that this has that serialized field to know what the label is. But the debug one, add that in, it doesn't care because it's just going to drop
because
in
it's
that
going to the
debug.
console. Yeah.
So now if we go to the game controller, you can see these three serialized fields. I can drag in the TMP one. Or I thought I could. Oh, I'm dragging into input handler again. Why am I obsessed with that? So drag the
Yeah.
TMP one onto here. It's still not letting me do it.
Hmm.
See real quick. TMP layer, yeah, it's got that.
Sometimes Unity has compiling issues.
Yeah, let me make sure I don't have anything. Clear that out. Go back here and make sure everything's public.
Um,
Yeah, yeah, publicness.
yeah, they both extend our level.
Okay, let's try it again. You get to see my fancy background. All right, let's try that again. Unity's gonna make liars out of us. It looks like it's going. See how these have the?
Yeah, so it knows it can. I don't know why it's not letting us right now.
It might be. Yeah, it might be some quirk with Unity being a pain in the butt.
Yeah, Unity just has to give us trouble. But I have done this many times, so I
Yeah,
guess you'll just
no,
have to take my word for it.
definitely. I'll probably have to restart. Well, if you want to explain it, I'll just try to restart and see if that fixes it.
Yeah, so here's the thing that I wanna get across with this, is we originally had the line text mesh pro label, and we're setting its content equal to whatever the ammo counter was, which means we are not just saying this label is using text mesh pro, we are saying it has to use text mesh pro. So the first thing we did by extracting it out is we said something is handling the ammo label, and then after that, we provided a method of doing that, which is text mesh pro. And what's beautiful about that is we can theoretically provide different implementations.
We'll try something real quick here.
Maybe if you don't make it abstract, I'm curious if it doesn't like the. No,
I,
it has
I,
to be. It has to be a
oh,
mono
you're right.
behavior.
You're right. I was wondering if having it at that level, but then I can't pull it up unless it's an interface. Let me get rid of the abstract, and we'll just make this virtual. I've done this a million times before too. I'm not sure what the
I
quirk
know. I
is.
don't know. I don't know why it's. Um, People are saying that the inspector is hidden by our window boxes or
Oh, it
spaces.
is.
Yeah.
Oh, it totally is. That's funny. Sorry, guys. Let me drag it over to this side. Sorry about that. That should be better, just easier to see. Well, yeah, there wasn't much to see anyway because it wasn't
It wasn't
working.
working. Yeah. See, that 100% has to work, but it's not for some reason.
Yeah, I don't know what the story is. I wonder if it's messing up because of the namespaces. Oh, this is the wrong namespace. I have two game controllers.
Oh, see, it's your fault. Okay, good to
Oh,
know.
for Pete's sake.
Ah,
I that's okay, that's interesting. So I dragged the one from the start here. I was using the one in the refactored namespace. I can almost guarantee that's what it is. Yeah, okay. That's
there
what
you
it was.
go.
That's what
There
it
we
was.
go.
Getting tricky with the namespaces. My bad.
Okay, okay.
So I just want to go back and make this abstract again.
Ah, good, because I was starting to go insane there, going, "I know this
Oh
works.
yeah, I was like,
Created."
why is this? Why are you the way that you are, Unity?
Good. So now we can get to a kind of an interesting point here. So, if you have a look, everybody, at the game controller, and you can actually see what it says, we are using the debug ammo label inside of the ammo label field, which means at the moment it will print all messages of the ammo to the console, but only to the console. But if we wanted to, we could alternatively drag in a different implementation, our Text Mesh Pro.
Hmm.
And now it'll go to Text Mesh Pro label. Now here's the thing. We didn't say the code doesn't change. In the game controller, the code isn't changing as to what implementation we're picking. We are doing this externally. And this is where things get interesting. One of the reasons you refactor out behavior is not just to have this freedom to click around like this, but you can actually start to think about adding. You can add things that were never conceived of at the point of designing the system.
Hmm.
So this is a little bit overkill, but I think it'll be a cool demonstration.
You say composite?
Of course, composite. You know I love my
I
composites.
know you do.
Just because I think it really demonstrates the endless kind of extensibility of a system like. So remember, we wrote this and the rule was something is given a update of the amount of ammo and we'll display it. It started being Text Mesh Pro. We then moved it to be console. Now we're doing something called a composite. And a composite, well, I'll let Charles do it before we spoil the surprise. It's probably it's self evident, but
Yeah.
it's
Look at
still
this.
cool every time I see it.
Bool.lang.
Oh, it's still there. Okay,
No.
I thought they fixed that.
Maybe I just need to update mine.
Yeah.
We do for each.
Yeah. And for all those purists in chat who are going to complain, yes, still technically for each is slightly less performant, but it's so marginal. It's not bad like it used to be. It doesn't generate garbage in the same way that it did in Unity 5. So the old scaremongering tactic of never use for each in Unity isn't true anymore. So don't
I'm
worry about that.
gonna move my hierarchy over too so we can see what that looks like. Oops. Come on. All right. So in the hierarchy, I'm gonna add a new one. I'm gonna call
Yeah.
this composite
Mm,
ammo label. Drag the
right.
composite, and then here we've got a list of them. We'll just drag both of them onto here.
Now, this may look a bit confusing, but I really want to. I'm gonna once Charles has dragged in the composite, I'll pause for a second to explain. So now we've got three options. We can pass in the debug, or the Text Mesh Pro, or the composite. So what we've done is we have fundamentally changed the features of um, the base algorithm. The algorithm is if some input, shoot, and then update the label. And nowhere in that code does it say anything about consoles or TextMesh Pro or anything else. But we can, at a configuration level, change whether it goes to a console or to TextMesh Pro or to both. And we don't have to stop here. We could have platform dependent versions of the UI. We could have an editor UI that goes to a different location than the normal one. We can have infinite complexity.
Mhm.
Don't have infinite complexity, please. It's a bad idea. But the point is that we
Not
have the
arbitrary complexity. Don't
yeah,
add arbitrary complexity.
yeah. But the thing is we've managed to give ourselves the freedom to, if someone came along and asked for new features, we don't have to rewrite code to add them. And this is literally the physical representation of the open close principle,
Mm.
because we are demonstrating that we can add new features like the ability to also print to the console that it's not written in the code that we have in our algorithm, because it is being extended without being modified.
And another thing that might happen is maybe there's some sort of validation. Like, I don't know, maybe if the amount it goes over some crazy amount that y- you want to foresee that could come through, you might truncate it or something.
Hmm.
So you add like a validation piece to this particular class that you don't need to add anywhere else. Yeah, there's so, and so that was what I was talking about refactoring with context. Like your context might be I need extra validation, or the context might be I need to optimize this because this is too slow, or additionally, you might have started out with just a regular text label, but then you're like, oh my gosh, the resolution is garbage. I'll go ahead and do the whole TMP import thing and start
Mm.
using TextMesh Pro now. But at first, you feel like I don't want to go through all that because I don't feel like waiting for it to import.
Um,
So you just have some cruddy looking labels for a little bit, but then you're like, oh, I'm ready to upgrade here. Yeah, or maybe you
to,
have advanced logging like log for net. And you're like, oh, I need to be able to
yeah,
log to a file here
I
as
used to use
well.
Rollbar a lot. Rollbar is great because it's
Yeah,
an
yeah.
external server that'll handle all of that for you.
Yeah. Maybe you need to call an API, to update something, if it's a multiplayer game. So, or if it's an MMO. It's been a while
Mm.
since we mentioned that, but yeah, you get the idea. There's so many things that you could do. Security. I don't know what security you need, but maybe you need to check against some amount that isn't valid. And
Mm.
I already mentioned validation, but yeah, all sorts of things like that.
Well, I guess like now that we've demonstrated the point, you could probably do a quick version of input because you've been
All
like
right.
subconsciously leaning towards input for the whole time. So
So I'm gonna see if I can quickly see if I can do a fancy way here. Create.
uh,
I want to see if I could do an extract.
the question we got here is would it be a bad idea to use an interface instead of an abstract class? Well, this is a much longer question. um, I would say I've already kind of talked on this before. I think people who program in C sharp give an undue amount of respect to the concept of interface separate from abstract class. I think they are both fundamentally the same thing, with the difference being interfaces allow for multiple inheritance. And it could be either, and it comes down to what you need. The general idea is you want to avoid, you want to favor composition over inheritance. So in general, you probably want to have interfaces so that things don't end up having giant nested abstract class base classes. But in this case, we have one, and it's fine, and we've no reason not to. Um, there's other specific Unity related reasons why we're picking abstract class, because to use interfaces in Unity, you have to use the new serializing reference properties, which I don't want to get into at the moment, but an abstract base class will work. So, yes, there are reasons why interfaces would be good here, but we don't need them. And right now, it won't add anything. And I think if there's any lesson we're trying to get across here, it's don't add things because they might be good. Add them because they are literally adding value. And right now, using an abstract class adds more value than using a non-abstract class, and interfaces currently won't add more value than an abstract class.
Why am I going crazy here? Oh my gosh, sorry. We're good. We are good. My bad. I had a little brain fart. We good. All right, so we got the input handler now as a abstract. It's funny. I got messed up because I was doing it all by hand when I usually just
Extract out.
yeah, yeah. All right, so I'm gonna move this to its own class.
Mhm.
And now let's go ahead and make like a keyboard input handler where or like maybe a mouse. I don't know, whatever.
Start with mouse. Yeah.
Yeah, yeah. So we'll take this. input handler. I'll go ahead and create a derived type. We'll call this mouse.
One question was what happens to all the other object components we're not using? Well, realistically, you wouldn't do this, right? You wouldn't just have arbitrary versions you swap unless you're literally demonstrating it on the fly. This is at configuration level. Having the freedom to do this doesn't mean you have to put in all implementations live in the project. The point here is that imagine these are prefabs you've pre-made. You can start a new project and drag in the set that you need, right? Drag in this project, we're using the mouse, and in this project, we're using the keyboard, and we're shooting rectangles. On another project, we might be using the VR input and we're shooting squares, whatever it is. It doesn't matter. The the whole like currently having all running instances in the inspector is purely to make this demonstration easier.
Yeah. So let me get cute here for a second.
Nice. Yeah. Ooh, fancy.
A little rich text never hurt anyone.
Oh, that was one of the comments we got in one of the other videos. Oh yeah, it was the one that I when I was on the channel for the day. Someone said that I'm trying to explain this concept about floats, and the thing they took away the most is they didn't realize you could put colors in the in the console.
That's funny. The other thing I'm gonna do real quick is just make a dummy gun, like
Yeah.
a null gun, just because it's gonna be a pain in my butt. I don't know. I'm gonna call this a gun. I'll call it my gun. That seems to be a fun thing that every tutorial has. My gun.
Yep.
So it's gonna have abstract. Sorry, this is just to make it testing easier.
Yeah, that's fine.
So public abstract float ammo get, and then we're gonna have public abstract.
So I hope as Charles is doing this, it demonstrates one point that we talked about before, which is someone said, why would you bother? There's only a few lines of code. Well, since those few lines of code, we've added multiple ways to multiple sources for messages. We're now adding multiple ways to fire the gun. You could add multiple variants of how the gun fires and whether it's using physics or whether it's using raycasts, and still our core game logic doesn't change. How
Mm-hmm.
cool is that? You fundamentally change your code so that it goes from being physics projectile based to being raycast based. Completely different implementation. And your code algorithm is identical. It doesn't even have to change. And that's sort of the point of all of this, right? And so refactoring out like this, it's not about the size of the function. It's about the actual dependency it has. It's what
Oops.
feature set it represents. So you can extract out even if something small, providing it is something that has its own dependency or thing or reason to change.
How do you get random numbers? What am I doing wrong with?
You're using math F. It's random. You need to use literally the random Unity
Oh,
engine, not random.
oh, that's right. All right. You get a range.
Yeah, range. It's just range. Yeah.
1, 2, I don't know, 999. All
Fun
right.
fact that'll it's upper bounds exclusive, so that's actually going to go to 1 to 998.
All right. All right. So now we've got our debug gun, which just puts that float to the, or rather prints that message. And now we can go ahead and wire all this up. Look how fast that was. And trust me, it's not because I'm like a especially fast typer or anything. It was just that easy to implement because we had it
And
all set.
realistically, like doing it live, there's other things that are slowing stuff down. This can be even faster if you get into the flow of doing this yourself,
Let's
and
do.
it's not even slow as it is.
We'll put the debug gun and the debug ammo label. Drag those up. Oh,
All right, so we're gonna make
oh,
okay.
oh. Let me. I'll leave that out. I'm gonna do the. What was it again? The input, the debug, or the mouse input. So mouse input handler. That's the one I was looking for here. All right. So let's see if this works, bro. If this works first shot, that'd be pretty funny. Let's see. No pun intended. First shot, get it?
Good one.
Oh, I did the. I don't count that as a fail. I just did the maximum on play. Let me drag up this console window. Clear this out. Hey, look at that.
Yeah.
Pew,
Okay.
pew,
So
pew.
now we've basically got the same game running, but we've vastly changed the implementation. It no longer uses a VR controller and a Tecnos Pro label. It is now using a console and a mouse click. But again, the algorithm hasn't changed.
Yeah, and as easy as that. And if it needs to change, we can change it. Now, again, what we talked about earlier was you want to let your requirements drive your refactoring. And, there could be a case like even now, like maybe a requirement is again we said I need to use Steam VR. We need to be able to support mouse input because I want this on multiple platforms. There you go. And then um, this composite ammo label actually helped us because now I can do logging without littering my code with a bunch of logging statements. And maybe for the build, I'll remove this composite ammo label and just put the text mesh pro in. So there's all sorts of contexts in which you might have requirements to support this sort of complexity. But just
And
because
another
go ahead.
I was gonna say, and another version of this that we haven't even really discussed is prototyping. Like
Mm,
right now,
yeah.
like sometimes the truth is you don't really know what the game's gonna be yet, right? You know, I want to shoot some stuff, but do I want to use raycast? Do I want to use physics prefabs? Like, what am I actually going to do? And so you make a strategy based approach, like we're doing here,
Mhm.
and you provide different versions. You can actually run your game and have one button that changes between which version you're using. So imagine every time I pressed, you know, E on the keyboard, it would toggle between using the different methods of labeling or the different input handlers. I'd be able to fundamentally prototype my game live with various implementations. So if you had like the gun will change its fire rate to different providers and different spreads, and it'll have different whether it's going to fire with raycast or whether it's going to be using physics. I could have all of these different options as keys on a keyboard, and I can like live prototype and test this because everything's a nice modular system that the algorithm is still the same. If I choose to shoot, do whatever it is I'm doing to currently shoot. And just with those two lines of code, all of the implementations could be vastly different because you've specifically designed your code around the fact that you're not coupling the implementation to the algorithm you're using.
Yep. Yep. Cool. So I think this is a great stopping point. We got through what I covered in the video and then some, which is nice. So I think this is going to be nice complementary, bonus material, I guess you could say, to the video that we put
Hmm.
out on Sunday. If you haven't seen it, let me see if it's still on my keyboard, my copy paste. Wow, it is. So I'm going on my clipboard. I mean, so I just pasted it in there. Check out that video. Give it a like, a watch through, and a comment. It really helps. Also, give this video a like. Also helps tremendously. I think what I'm gonna do is so you've all seen me write the code. So if you want to go ahead and watch this stream and copy it, you can. But I think I'm going to take this code that we wrote in this live stream and I'm going to release it as a patron bonus. So I'm just going to package this up into a Unity package and I'll add a new post to my Patreon page. That will just say bonus content. It's going to have the same thumbnail as the video. So feel free to go ahead and download that. If you're a patron, if you want to support the channel, please consider becoming a patron. Otherwise, honestly, you could just watch this and copy it yourself. If that's easy too. So yeah, thanks for joining. If you have any additional questions, please join us on over on the Discord server that we have. There's a link in the description. Jason's on there all the time answering questions. We have other folks. Forgive me if I miss anyone. We have Mateo. We have Trond. A couple other people that are always pretty active and answering good questions. So join us there. And you have any closing thoughts, Jason?
Yeah, I just want to answer one last question as we
Shoot.
go. Daniel asks, I know this might not be the right time. Well, we'll cover it.
Yeah.
But I have a question about events. I've heard you talk about events and that you should avoid them for time critical code. Why? Oh, as Charles was giving the closing statements, I was forming a metaphor that I hope will help. So the idea is, if I have some piece of information, which is basically what an event is, that I want to give to somebody else, the equivalent would be I have a box. And what I do is I put the information in a box and I hand it over to the person next to me, who then opens the box and takes the information out. That's not a lot of work. It's a small amount of work we're both doing arbitrarily when we're both standing beside each other. When do you really put something in a box? Well, when you're sending it out to be shipped somewhere and it could go anywhere at all. You have no idea, you have no control over where it's going. Multiple people could want to see it. You might want to travel in multiple locations. The box has value in that it turns it into something that is distributable outside of yourself. In that there's that little bit of cost that if you're sending messages back and forth, you're having a conversation. Imagine you weren't talking directly, you were writing notes down and handing them to each other in a box that you'd open, read, write your response, and put it back and forth. That's an arbitrary waste of processing, and it's very slow, and it'll basically bog down the conversation you're having. And that's the equivalent of an update loop. You don't want events being the mitigator of conversation between two things that are literally beside each other that you control. You want to cut out all of the fluff. But a system that might plug in at the side that might interact with your system, events are fine because you're packaging what's happening and sending it out and saying, someone else might want to respond or react to that. And that box doesn't just contain the information of what the event was, but it contains who sent it and under what conditions and what extra information there is around it. And that can be used by things like external loggers.
Yeah.
Like, for example,
A
when Facebook
DTO.
is watching your messages being sent back and forth, that could be used for them to pay attention. But it's not necessary for you talking to your friend to go through this whole packaging process. So that's basically the point. Don't use events for things that you can literally write code that will talk back and forth to each other. Use events for something where an external system that you want to have no knowledge of each other talk to each other, like a mail system delivering one thing from a package from one place to another. That's two completely separate entities, two separate life cycles, and you're using the event as a transition, transfer medium. But it's completely different than the case where you're calling two methods like if mouse pressed do whatever.
Mhm.
That's why I'm not a fan of event-based input systems because it's basically turning this thing that could be happening in real time into a packaging message distribution thing, which I kind of think is unnecessary.
Yeah.
So there we go. Those closing
Cool.
thoughts on events.
If you have any additional questions, again, Discord or leave them in a comment on this live stream, and we'll do our best to get back to them as soon as we can. All right. Also, look for that code. I'm gonna try to post it. It's gonna take me a little bit just because I'm gonna put it in its own namespace called Livestream. So just look out for that. Probably by the end of the day today, my time, Eastern Standard. It's like 7 a.m. where I'm at, right? So end of day, my day. All right. Well, thank you all for joining. Appreciate it. We'll be streaming next week, so keep out for that. Keep an eye out for that. All right. And also, I got a video coming out on Sunday on dots, most likely. So set your notifications or whatever you do. All right, guys. Take care.
Good luck.